This video is going to teach you how to solve trig equations. Now, we've done this before. We're just kind of bringing it back to what we've been working with recently. So we're on page 8 of your packet, and we'll go ahead and jump right in. Just a quick heads up, our properties, our identities, still do apply for some of these, but of course, to be able to solve for x or to be able to solve for an angle or theta, you do need to know your unit circle. So if you haven't yet learned that, please get on that. You will need to know it yet again. So number 1, you have sine of x minus square root of 2 equals negative sine of x. So what we want to do is go ahead and combine like terms. So what I'm going to do is add, from the right side, I'm going to add this sign over, so that this cancels, gives me 0 on that side, and here I have 2 sine of x minus square root of 2. Now, of course, I do want to get x by itself, so I need to first get these numbers out of there. So I'm going to now add square root of 2 on both sides. So now I have 2 sine of x equals square root of 2. Now I'm going to go ahead and divide by 2 on both sides, and I get sine of x equals square root of 2 over 2. So now if you remember something that looks like this, we've done this before, this was on our very last unit actually. So we want to think, where is sine square root of 2 over 2? So technically, if you were to rewrite this, technically you would say, that's right. Technically, we would say x equals, to get sine over here, we would have to take the inverse, remember? So sine inverse of square root of 2 over 2. And because of that inverse, that opens us up to having 2 separate answers. So now you have to think, okay, which 2 angles is square root of 2 over 2 your sine value? So of course that's a pi over 4 family member. So we know that's true at pi over 4. And at 3 pi over 4. And those are your answers. Number 2, same idea. There's nothing really to combine here, so I'm going to go ahead and get sine squared, in this case, sine squared of x by itself. So I'm going to go ahead and add the 3 over. And I have 4 sine squared of x equals 3. Now I'm going to divide by 4 on both sides. And I have sine squared of x equals 3 over 4. And you're probably thinking, well, that's not a fraction on the unit circle. We're almost there. See that square? You do have to actually get that square out of there. And the most legitimate way to do that is to go ahead and square root both sides. So you do get sine of x by itself here on the left side, but because we've put in that square root where it did not originally belong, I need to make sure that I cover that. I justify it with a plus or minus in front of the square root of 3 over 4. So now sine of x equals plus or minus square root of 3 over 4. Now what I'm going to do is to actually simplify that. I'm going to separate the square root so that you have a square root separately for 3 and a separate square root for 4 as well. And the only reason I can do that is because I have 3 divided by 4 here. If there was some addition or subtraction going on under the square root, you couldn't separate, but because I do have division, I can go ahead and separate the square root. So I have square root of 3 over square root of 4. Now square root of 3, we don't know what it is, but square root of 4 I know is 2. So really, we're looking for square root of 3 over 2, plus and minus. So, and we're looking for a sine, so, oops, sine of x now. So technically, we're looking for a sine inverse of plus and minus square root of 3 over 2. So we should have 4 answers where sine is square root of 3 over 2. So our answers are all of our pi over 3 family members. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Number 3, we're going to bring everything to one side. Now, on this one, unlike number 2, and unlike how number 1 worked out where you ended up getting a 0, This one, we do actually have to get this equal to 0 on the right side. So I'm going to say this must equal 0 for me to do anything. So I can't divide by sign because that 2 then is going to still be there. So what I'm going to do is actually subtract the 2 sign all over. Oops, I forgot the 2. So then I have sine squared of x minus 2 sine of x equals now 0. So now I have sine squared and a sine, but no extra number. So no, it doesn't factor, but I can pull out a greatest common factor, and they both have at most one sine that I can pull out. So let me pull out one sine, and inside I have remaining sine of x minus 2 equals 0, which gives me 2 equations to solve. So I'll solve that first one, and then I'll solve the other one. So now I have sine of x equals 0, and I have sine of x minus 2 equals 0. So coming back to that first one, sine of x equals 0, technically I'm trying to find where x, I'm trying to find an angle so that, or where sine is a value of 0. So sine is 0 at two angles, right, 2 places, 0 and at pi, and technically because it's 0, 2 pi would also be a legitimate answer only if our instructions allowed it. Now, if you take a look at our instructions, what I've highlighted here, it does say that your answer has to fall between 0 and 2 pi, but it cannot equal 2 pi. So what I'm going to have to do is actually knock that out as one of my answers. So my only 2 answers really for that part, for that equation, is 0 and pi. Now my second equation, I'm going to add the 2 over so that I have sine of x equals 2. And technically we would have to say x equals sine inverse of 2. So in other words, where is sine 2? Now if you think about the unit circle, we've talked about this several times, there is no place where your sine value is 2. There's no number that's greater than 1 that's on the unit circle, so this actually does not exist. We can't solve that one. It's outside of our domain. So there's that. Number 4, if you take a look at that, you have sine squared, you have sine, and then you have a number. And yes, this one does factor, so hopefully this is bringing you back some memories. So I'm going to simplify this. I'm going to write all of the signs as a simple x for now, just to make it easier. So I'm going to say that's 2x squared minus 3x plus 1 equals 0. And if I factor that, and go ahead and pause the video, take a minute to factor that and make sure you are okay factoring, but it should give you 2x minus 1 and x minus 1. Now that we have our factors, I'm going to put the sign back in. So wherever I have an x right now, I'm going to put in sine because that's what we originally started with. So that's really 2 sine of x minus 1 and sine of x minus 1 equals 0. So now I can go ahead and solve these separately. So here, the first one I have 2 sine of x minus 1 equals 0. And just to fast forward a little bit for you, once you do get sine of x by itself, you should get a half on the other side. And then the other equation, I will get sine of x minus 1 equals 0, and if you take the 1 over, you get sine of x equals 1. So on the first equation, I need to find where sine is positive a half, and on the unit circle, that's at pi over 6 and at 5 pi over 6. Okay. On the second equation, we need to find all the places where sine is a positive 1. And there's only one place where that's true, and that is at pi over 2. There you go. Number 5 is an interesting one because this is going to involve what you know already, how to solve equations and things like that, but it also involves your trig identities. So if you take a look through, you have secant squared and tangent squared and then a number. So this looks like it's almost going to factor, but it doesn't because you have 2 different trig functions in there. So to make sure that we have that we're working with the same trig function, I'm going to change one of these based on my trig, or using my trig identities, so that we're working with the same trig function. So I'm just going to, because it comes first, I'm just going to attack that secant squared, and I'm going to rewrite it in terms of my Pythagorean identity, because remember, 1 plus tan squared of theta equals secant squared of theta. So I'm going to use that, and instead of secant squared, I'm going to write down this identity. So really, I'm going to write it down like this, 1 plus tan squared of x in this case. Okay, so now we have all of the same kind of trig function, tan and tan, so now we can actually work with it. So I have a 3 hanging out at the front. I do need to go ahead and distribute that through. So I have 3 plus 3 tan squared of x, and then just drop everything down. Minus 2 tan squared of x minus 4 equals 0. Now I'm going to combine like terms. So I know the 3 minus 4 will give me minus 1. And 3 tan squared minus 2 tan squared will give me just 1 tan squared. Now I can just go ahead and solve the equation. So I'm going to go ahead and take the 1 over. So I have tan squared of x equals 1. And because the tan is squared, just like on a previous problem, I do have to take the square root. And because I'm taking the square root, I have to put in a plus or minus in front of my answer, or in front of the value. So really, that breaks it down to 2 equations. So I want to solve tan of x equals positive 1 and tan of x equals negative 1. So really, I'm solving for where tan is a positive 1. So tan inverse of 1, and that is only in the first and third quadrants. So here your answers are pi over 4 and 5 pi over 4. And with the other equation, I'm looking for a negative 1, so really we're looking for x equals tan inverse of negative 1. And tan is inverse only in quadrants 2 and 4, so my answers here are 3 pi over 4 and 7 pi over 4. There you go. Number 6. It looks very close to something that could possibly work with the Pythagorean identity that's with sine and cosine in 1. However, it's not, there's nothing there that's squared. So what I really have to do is force this to be used with the Pythagorean theorem, Pythagorean identity. So I know the Pythagorean identity that I'm thinking about is sine squared plus cos squared equals 1. Now I have a sine plus 1 and I have a cos on the other side, so let me actually see if I can rewrite this identity so that it's cos by itself, not even cos squared, just cos by itself. So let's see, if I subtract the sine squared over, I get cos squared of theta equals 1 minus sine squared theta. Okay, now the only way I can get cos squared turned into cos is by square rooting both sides. So then I get cos theta equals the square root of 1 minus sine squared of theta. So what I'm going to do is I'm going to replace this cosine with this entire little rewritten way of the identity. So I'm going to put this right here. Okay, so let me rewrite that. Here on this side I have sine of x plus 1 equals now the square root of 1 minus sine squared of x. Okay, so now I have the same trig function, which is nice, and so I can just work with that. Now the only way I can get this sine squared out of the square root is by taking away the square root, and the only legitimate way to do that is if I square both sides. So on this side it works out nicely because they just cancel, square root and square cancel, giving you 1 minus the sine square of x. But on this side, I actually have to FOIL it. So take a minute, go ahead and actually FOIL this, so it would be sine of x plus 1 times sine of x plus 1, so by times itself. So once you actually FOIL it, you should end up with sine squared of x plus 2 sine of x plus 1. Now I have sines all the way through and I have a 1 all the way through. So what I'm going to do now is to simplify this. I'm going to bring everything from the right side because there's less there to work with. I'm going to bring all of that over to the left side and just combine like terms. So I'm going to subtract the 1, and then I'm going to add the sine squared. Add the sine squared. So that's all gone. So now I have, let's see, I have sine squared plus sine squared, so that's 2 sine squared of x plus 2 sine of x, now the 1's go away, equals 0. So just like a previous problem, I can actually pull out a GCF again here, and the GCF here is 2 times 1 sine. So 2 sine of x is what I'm going to pull out, leaving inside of parentheses sine of x plus 1, which gives me my 2 equations to solve. And so this one right here, I get 2 sine of x equals 0. And if I divide by 2 on both sides, I end up with sine of x equals 0. Now, sine is 0, like we mentioned before, at 0 and pi only, because we still have to remain within our restrictions based on our instructions. And then my second equation will give me, let's see, sine of x plus 1 equals 0. Subtract the 1. So sine of x sine of x equals negative 1. So x equals sine inverse of negative 1. And sine is negative 1, only at one location, and that is 3 pi over 2.